Hello.
Hello, Bhumik.
Hi, Rohi. I'll just share my screen. Give me a minute. We'll wait for 1 minute, see if anyone else joins, else we'll start.
Sure.
Okay, most probably we can start. So until yesterday or until the last day, so what we have done is we have fixed some problems, uh, and we have got the data in quite good shape now, but there is still that one problem that we have to fix. So what we have done is we have looked into the data definition, we have looked into the variables, the data types, we looked into the missing values, which in our case there is none. Um, just a moment. Yeah. So we looked into the data types. We found the fields which are character or categorical fields, and we have already dummy encoded them or one hot encoded them, right? So that we have already done. Now what we are doing uh, is that there is still one field which we have to take care of. Actually, there are two fields. So first of all, we have to get rid of the customer ID field. Maybe we can do that first. And to do that, a very simple method is telecom is the data frame, right? And then we can say drop, and we can simply specify the column name, which in this case is the customer ID. So I'll just copy it from here, and I put it over here, and then I say axis is equal to 1 because I want to drop it from the columns. It is a column, hence axis is equal to 1. And I say in place is equal to true. The moment I do that and do another information query, I can no longer see the customer ID. Now, because we are focusing uh, in these sessions, right, we are focusing on machine learning. That's the reason why we have gotten rid of that variable. If I would have been redoing all my EDA and visualizations and so on, then I would most probably keep the customer ID, because then I can use the customer ID field, right, to take the count. So it is like writing uh, plain old SQL queries, which we have seen earlier also when we were going through MySQL. So that ID field can be used as that specific column, which we can use to take the counts. Example, I would like to know, let's say, how many senior citizens or the categorization of the senior citizens are there. Using a query like structure, and then most probably I can put it through uh, the matplotlib or pandas data frame or the visualization options which we have, and then we can try to visualize it. So to visualize that, we may more often than not need this ID field, because then it becomes very simple for us to get the counts, right? But that is not to say we always need that. We have other ways. For example, we have commands like value counts and things which we can use, right? Now, we also have to work on the total charges field. This is something which we stopped on that day because we are not able to convert that. So let's try that now. It is marked as an object field, but if we look at the data, then we'll find that it is actually a numeric field. It is represented as an object, but it is actually a numeric field. So can I represent this as integer? So let me just try doing something like this. Will that work? Is the question. I think it is trying to get all the data, but we cannot convert a series to class int. So most probably this technique will not work. So let's go back to our documentation and try to do an as type. So I was looking at some documentations earlier also. Let's try to do that. So I'm going to say pandas convert. Yeah, I think this was the link that I was going through. Yeah. So yes, this was one of the links. So this person is also having the same problem, and this command, we tried this does not work. So I would just like to try this one now. Let's see if this works. So I hope we have imported NumPy. Let me just quickly check if we have done that. Have we done that? No, I'm not able to find it. Okay, so let me import NumPy. Import NumPy as NP, and now let's paste this command over here, and I'm going to make the changes. So I'm going to call the data frame as telecom. Here I'm going to take total charges, and I can replace this thing. I can actually delete this thing because I don't need this, and then I can try to run the command. Let's see if this works. Now string objects does not have as type. That is where the problem is coming. So let's see what we could do. Yes, this is a good thing. This is a lambda function. Why not try and use this? So I'll keep that error here because that is just for our reference that it did not work. So I'll keep that line there, but let me do a telecom.apply lambda call pd to numeric call. Yeah. So what we need to do over here is this call field is what he's trying to convert, right? So yeah, I think we have to replace call with total charges. So I can just replace this. No, I will just use the name as total charges, and I will use this over here. Let's see if this applies. I think it has applied. It is giving me a data frame. So let me just select total charges, and I'm going to do type on this. Okay, just to ensure that whatever I have done is right. So it's giving me correct value, but I'm still not convinced. So let me just do one thing. Let me go to the end and do an info. So it should Mm. Oh, sorry, I missed a bracket. I missed a bracket. Now it should work. Yeah, let's see if it has converted. Yes, yes, it has converted now. Very good. So what I do now, I'll take this command and I'll come over here and I'll say telecom. Okay, telecom is equal to this. Now I should have my data frame, which is something like this. You see, all the fields are now numeric, and clearly, you do remember that the reason why we are doing this is basically we are preparing the data to the requisite numeric format. If we don't do that, is the model going to work? The answer is yes. But then the convergence of the model to the accurate classification or the decision boundary is going to be difficult. Let's quickly talk about what is the decision boundary. We have already seen this, but I think we should just quickly revise that. So our logistic regression function is going to look something like this, right? And I have my zero values here. So I have my class 0 over here, and I have my class 1, which is over here. So in my context, in my use case, the one that we are doing over here, 1 means the customer has churned, 0 means the customer has not churned. So this is churned and this is not churned, right? Now, what we are trying to find is the best decision boundary. So the one that I have drawn is not a best one. Will this be a best one? The answer is no. There are still misclassifications here. The one which will be a good one should most probably look something like this, or something like this. Now, out of these two lines, this is, let's say, line 1, and this is, let's say, line 2. Please don't get confused. This is not a L1 or L2 regularization. Okay. Now, this is just line 1. This is one of the decision lines. This is one of the decision lines. Or maybe what I can do, let me just clear the diagrams and draw it in different colors and using a line. So I have one line which is this, and I have one more line, let's say one more line which is this, right? So I have a blue line and I have a green line. I hope you can see it. Now my question is, which line do you think is a good line? Is this one, which is my blue line, let's call it line L1, or is it my green line, which is my line L2? Any ideas? Any idea, Rohit?
No, Momik.
Okay, okay. See, the concept that I just wanted to explain is because if you look at this blue line, right, it is still closer to this point. It is a bit closer to this point also, right? But it's really very close. But if I look at L2, the distance, right, the distance it has from the closest points, which is this, is quite good, which means I have a good confidence, or I have a better confidence with respect to the line L2 as compared to the line L1 in this case. Now, this concept that I'm talking about is not really directly applicable in case of logistic regression, because for logistic regression being a very, very simple model, um, just a moment. So logistic regression being a very, very simplistic and probabilistic model, it is really, really crucial for us to have the points clearly bifurcated. That's all we are trying to do. We will see more advanced models on classification, which looks into far better implementations. And that is the reason why we have other things. Yeah. So in this case, this kind of a bifurcation or a comparison of these two decision boundaries given by line L1 and L2 is not really a right. It's a discussion or a point to be concerned about right now, because the objective, right, the upfront objective, which we have over here, to at least to do the classification, and that we can do, because as we have already discussed, we are ourselves going to decide that a decision boundary, right? Because the decision boundary is not the outcome of a logistic regression model, right? The logistic regression model simply gives you the model. It gives you the line. The model is going to return us with this line. That is my logistic function, or my sigmoid function, or my S curve, and there are many names. So that's the output of my model. My model does not give me the best fit line or the lines at all. The decision boundary will be decided by me. I'm going to decide, okay, if the probability of somebody churning out, or the probabilistic representation of that value, is more than 0.7, I am quite sure, okay, I'm quite sure that the person will churn. So that value of 0.75 is chosen by me, or by my business, or by my product owner, or by my uh, manager, or by the person who has decided the context, or the one who is designing the experiments, or a senior data scientist who has a very good domain knowledge, or it might even be me, right? Because I've done this a lot of times, let's say in the past, and I've got good results with a decision boundary of 0.75, and hence I'm going ahead with the decision boundary of 0.75 as of now. Later on, I'm going to change it basis the kind of feedback that I get when my model goes to production and its outcomes are getting used to my business, right? So obviously that value will be decided by us, because that value will lie somewhere over here. If you see, there is an intersection point over here. So let's say the intersection point of 0 point of L2 is approximately 0.75, and the intersection point of this line L1, okay, is approximately 0.9. So having a decision boundary which is 0.9 is also giving us the same results as we are getting from a decision boundary which we have fixed at 0.75. But I would personally prefer going with a line which is more generalized. In this case, that line will be L2, and my decision boundary hence will be 0.75, right? Now let's go ahead with the further implementations. Now we are going to do the actual modeling part. When we do the modeling part, obviously we will be using the inbuilt functionalities of sklearn. Will again follow the same thing. We'll import the libraries and we'll go ahead. But first, I see there is a questions. Oh, go ahead, Rohit.
Shouldn't it be the case that L1 is a better line because it helps in a better classification? Like we can easily determine whether the value is 1 or 0 with the help of L1, and not so surely with the help of L2 line.
Yes, yes. Actually,
But
you are right. But that will be applicable for cases when you have clear demarcation. In our case, we have a very clear demarcation, or we already know, or we are able to visualize it, that 0.9 is a good point. Now, what if tomorrow you have points which are represented as 1 or 0, but in reality, they are falling somewhere over here. So as per your data, you get a new point which is somewhere over here, which is very close to the blue line, right? Now, this raises the eyebrows, if you know what I mean. What I mean by that is, if you imagine having an output which looks something like this. This is your S function, yeah, and I have 1 over here, I have 0 over here. So this is my 0, this is my 1, and my decision boundary is chosen as 0.9. So my line is something like this, let's say. Okay, to explain a line like this, or to explain a line like this, it will have a slope also. So to explain a line like this, which is quite closer to many points which are there in the data, or the probabilities of the points which are there on this side, is very difficult. Why? Because that line is very close to the points. Now, the moment the line gets very close to the points and you explain to your clients, or you explain to your managers who are working in the business, that this is the line which is bifurcating it, and they see a problem that I have some points which are marked by this O, and it is really below my decision boundary. Let's say this is the one that I have chosen, right? So this is L1 and this is L2, let's say, and you have chosen L1, right? So there are these cross points which are falling very, very close to L1, and there are 0 which is really very far from the line. This gives a very simple and direct intuition, a very logical intuition to whomsoever is looking at this visual, is that the line was able to properly demarcate all the 0 points. But if we get a cross point, now it is going to become very difficult to explain or to justify my model, right? Why it is becoming really difficult is because the line now is closer to the crosses, and people might have this kind of an intuition looking at this diagram or looking at this representation, that there is a good probability that this line might do something wrong. Now, please don't get confused with the fact that I'm scattering the 1 points over here. Why I'm scattering the 1 points over here or the 0 points over here is because ultimately 0 and 1 will be the data points, obviously, but these points that I've drawn over here will be their probabilistic representations. So finally, we will come up with a model which will give us this line, which is my S curve, and also the probabilities of each and every point being 0 or cross, or circle and cross, or 0 and 1. If those probabilities lie quite close to the line, then it becomes a problem for you to explain the model. The best model in this case, I would strongly recommend, will be something which looks like this. If I have a model which is dividing these point probabilities into half and half without any overlap, without any point coming closer to the line, that's the best line to be used by the business, because that's the best line or the best fit or the best demarcation which we as human beings can understand without any point of doubt. The moment people try or see a point where there is even a single percentage of doubt, right, on your model, people will become hesitant and your model will never reach the production stage. This is a very, very common issue with any machine learning problem. You can explore it yourself, you can read blogs, you can talk to your seniors in your organization also. There are many cases where models do not reach the production stage or the usability stage. And one of the prominent reasons why they don't reach there is because of the doubt factor. A doubt factor will always be there. Why? Because this is not a code that you have written. This is not a logic that you have created. Somebody has already created the algorithm, right? And you are simply the consumer. You are simply using it. Even the libraries you have not written, right? You're not going to write the logistic regression equation or the formula or the gradient descents that we have seen using some programming language like C, C++, until or unless you are working in that industry which is forcing you to do so. In the financial institutions, maybe you will have to. But then if you have a scenario like ours, where we are simply importing a scalar and we are creating a model, what is the guarantee that your stakeholders, your client will believe your model? You have to make them believe that your model is correct. And the way to do that is to generalize your model, right? It is as simple as, let's say I have, and we will see these kind of problems again. Let's say I have some points of some kind of customers who are represented by this X, and there are some customers who are represented by this point 0. I would like to create a decision boundary. Obviously, if I create a decision boundary, which is something like this is one of the best, right? In this case, this is really one of the best. It has clearly demarcated all the points. You see, there can be errors, right? But it has done a very good job. So what if I have a point which is over here and I have a point which is over here? So this is a cross, this is a 0. Okay. Now I'm trying to create a model which looks something like this, right? This line, okay, this decision boundary that I have created is really very good. It is absolutely good. You see, there is not even a single case that I have identified wrongly, right? But is that explainable is the question, is because this line, first of all, is very, very complicated, right? Nobody will try to relate to this line because this line is really doing a hard job. And we all know what this problem relates back to. This problem can relate back to overfitting, right? Rather, if we had a line, which was something like this, right? A decision boundary which was something like this, which is kind of a generic line. It is not really a very, very specific line. It is a generic line, right? It has already miscalculated points. You see, 1 point here is miscalculated, 1 point here is miscalculated. This is acceptable. If you show this to your business, right, the business will actually believe you. It will believe you because you are actually doing something which even humans do, right? Even humans are going to do mistakes. If you go to a COVID-19 center and you have me tested there is a probability I don't have COVID-19, but they have tested me positive, right? Obviously, I will get angry. Obviously, you will get angry. Obviously, people who are there will also get angry, right? They'll have some sense of doubt, but they will sooner or later understand that the person who is doing this test is a human being, and that person is bound to make mistakes. So there will be mistakes, right? 1 out of 100 people will be diagnosed wrongly, right? What if I tell you I have developed a system which can do 100% accurate job in identifying a person who has this disease? You will have a fear of doubt. How is that 100%? Nobody in the world has done that. How have you done it? Right? What kind of a technology have you used? So that's the kind of doubt factor that will come to this line. Why? Because this line is closer to this point, right? It has just classified this point. It has just classified this point. So that's the reason why your business may not like the line L1, right? But they will prefer the line L2, even if the line L2 is going to do any mistakes. Was that clear?
Yes,
Yeah.
that's clear now.
Okay. Let's do one thing then. Let's scroll down and let's try to yes. So what we are going to do now is that we will try to model, and we will see what kind of problems we see in the modeling, and then we are going to treat that. Okay, so first of all, let's again look at if there is anything which is missing. Quickly we will check that, and we will do that using is na dot sum. If I do an is na dot sum, you see what is happening now. Total charges has now 11 values which is missing. Earlier it was string. Now I have converted it into number. Because I have represented this into its actual or required format, I could see a problem. But is that really a problem? This is a very, very important question. This is a really very important question. I can write it down and give it to you also. So let's try to write it down. If we have missing values in my data, what should I do? This is completely, okay, this is completely a question to be answered from a perspective, right? But you can also answer this using your logic, using your business logic. Example, if you have missing data, how many total rows do you have in this data set? Let's go up and let's see. 7043. 7043 rows are there. Okay. How many number of missing values do you see in the total charges field? 11. Okay. So what is the percentage? 11 divided by 7043. And then I'm going to encapsulate this into brackets. And then I'm going to multiply this by 100. I get a percentage, which is 0.15. I have actually multiplied it using 100, right? So this is already converted into percentage. This is 0.15% of data which is missing. So using this as a background, I'll say if the missing data is very less, right? Then I'm going to define some kind of benchmark, let's say less than 2 to 4%. And this value is going to change. Okay, this value is really going to change. There are some cases where you would not like to take any risk. You are going to impute, and we are going to come to what is the meaning of that word impute. But prima facie, what anybody will do, if you have any missing data in any one or more columns, which is less than 2 to 4% of the total data, like our case, we can drop the rows. As simple as that sounds, right? Because you are losing hardly what 0.16% of the data in this case. If I round this, right? If I round this, I can clearly see that I'm losing what? 0.16% of data will be lost if I drop all those rows. Are you confident in doing that? In my view, I am. If you are not, if we are not in a position to do so, then what do you do? In that case, we impute the data. What is the meaning of imputing? Imputing means filling up the gaps. Impute is equal to, just a moment. Yeah, impute means filling up the gap. Sorry, gap, not GSP. How do you fill up the gap? Clearly, if you have a data which is not normally distributed, which has outliers, which is heavily left skewed or heavily right skewed, in that kind of a scenario, if you impute these missing values with the average of the data, you are doing a mistake. Howsoever small the missing rows might be, in our case, it is hardly 0.16%, not even 1%. But if I have to impute, I must choose the right way to impute, right? So if we have outliers in the data, or the data is heavily, okay, left skewed or right skewed. So LS means left skewed, RS is for right skewed. So if I have outliers in the data or the data is heavily skewed, then we suggest, okay, we suggest using median. So we'll take the median of that column. We'll take the median value of that column. The median value can be found out from the library like dot mean. So dot mean function can be used, or dot median function can be used, and we can find out the median, and we can replace the null values. Okay, we can replace the null values with the median value, right? If we don't have above case, it means we don't have outliers, we don't have heavily left skewed or right skewed kind of a data, then we can survive. Okay, survive is the right word. We can survive using mean of the column. So we simply impute. Okay, if we want to impute, in our case also we can impute. In my case, I'm not going to impute because I don't think I need to impute in this case. I have hardly 0.16% of data which will be lost if I drop the data. And to drop the data, I know what is the thing that I'm going to use, drop in. Right, I'm simply going to use drop in and I'm going to say in place is equal to true. The moment I do this, the moment I execute this code, it is going to drop all the not available values or all the null values from the data frame. In this case, this 0.16% of data which is missing from the total charges column will be dropped. Is that the right thing to do? In my view, it is the right thing to do. Maybe in your view, it's not the right thing to do, in which case you have to impute the data. How do you impute the data? You have functions like telecom dot fill na. I have to check if it has the underscore or not. We have to check the documentation. I remember it having the underscore, or maybe it is something like this. So fill underscore na or fill na is the function. Here, I have to put the values inside this function, which I would like to change. So I would like to fill the gaps for what? I would like to fill the gaps for the total charges. So rather than taking the entire data frame, I'm going to take this. Okay, total charges fill I'm going to take, and I'm going to fill it. Okay, I'm going to fill that with the median. So I will calculate the median of that field, the telecom total charges, and I will simply fill that over here. How can I calculate that? Can I really calculate that? Let me see. I can say telecom total charges, and I can do a median, right? And I can also do telecom total charges, and I can do a mean. Right, this is not a very efficient way of doing this. I have a very small data, that's why I'm doing this. I would strongly recommend using np.mean, using numpy's mean function. Numpy mean function is excellent, right? It is excellent. Pandas is not that good. Even if There are many functions in pandas which are just a high level abstraction of numpy functions. It is always recommended in the industry, you should always use numpy because numpy is very, very fast, right? When you have GBs and GBs of data, then you will come to know how good it is to use numpy. So in any case, you will find the median, you will find the mean. You can go ahead and fill in it, right? You can go ahead and fill in it by doing this, something like this. So you can take this output function over here and you can say in place is equal to true, right? So either we do this or we do this, right? So I'm just going to delete these two fields and I'm going to convert this column into a comment field and I'm going to say uh, we could also have, right? We could also have imputed the values like the example below, right? But in this case, I'm going to do this. So I'm just going to run this command and I'm going to see the information of the data frame now. It has 7032 rows. How many did it had earlier? It had 7043. 7043. I have already gotten rid of my 11 rows. Everything else is intact. Everything else is intact. So this is how it works. This is how this drop NA function works. But then even a better version of using this drop NA will be to use the column name. So we could have also said telecom and then inside brackets the column name, the one that we want to operate on, and then we could have used the drop NA function with in place equal to true as the value, right? In that case, we would only operate on one column because if I do a drop NA function on the entire data frame, it is acting on all the columns. But I have not checked all the columns. In my case, I am really lucky that I have only one column where there are 11 missing rows, right? I'm really very lucky, right? Now, uh, since we have no missing values right now, we can go ahead. We can go ahead with the modeling part now. So before we do the modeling, let's try to understand what we have to do when we do the modeling. Clearly, we have to um, create the training and testing, right? We have to create the training and the testing data, right? So now there is a small problem which we are going to face. So first of all, let me import the library. So from sklearn model selection, import train test split, right? So I have this library, you know this, we have already used this earlier. Let's give it one time. I don't know why, but today my laptop is crying. So let's give it 1 minute of time to import the function. Then, as obviously, we will create the training data set. We'll create the testing data set by creating two variables. We have done that earlier, X and Y. Now, when we are creating X, earlier when we were doing the linear regression use case with the Boston housing prices, well, what we were doing at that time is we were simply writing the column names, right? We could do that now also, right? But there is another very cool way of doing this, in which case, just give me one moment. Okay, yeah. So what we are going to do is that we are going to create this X variable, okay, by doing something like this, telecom, okay, and I'm going to use the drop function, and I'm going to pass the variable churn. Why? Churn is my target variable. I am creating a new data frame X from the data frame telecom by dropping the column churn. You see, I am deliberately not using that in place equal to true thing. If I do in place equal to true, then churn column will be permanently gone from my telecom data frame. I have to rerun all my cells. Okay, please keep that in mind. Very important. Don't use in place equal to true in this case, but you have to use access equal to 1 because it needs to identify what is that you mean by churn. Churn is actually column, it is not a row. So I can run this and my X is created. Okay, now it is saying churn is not found in access. I believe I have done a mistake by creating this as capital C. No, it's also not in the Y. Is it not there? No, it is not there. Why is it not there? Let me go back and see what mistake I have done. Let me go back. Did I drop that column earlier? I think I have dropped that column earlier. That's where the mistake is. I was dropping a lot of columns, right? I believe I have dropped that column. Var list 1, 3. Let me see. Yeah, I think I have done so. Yes, see, I have done this over here. I think I have done that. So give me 1 minute. Let me, yes. So before I do this, let me just do what I should have done is that I'll add a new column and I'm going to say, what am I going to say? Print var list. Then I'm going to take a copy of this and do 2 times. I'm going to say var list 2 and var list 3, and I'm going to print this. Do I see churn? Yes. See, here is the problem. Here is the problem. So what I'm going to do, I am going to say, let me do one thing, is that very easy. Var list is equal to, I'm going to just take this thing. I could have done it in a different way also. I could have used the pop function, but I'm not going to do that here. I will do this. So I'm creating var list, which now does not have the churn function. And let me rerun all of my cells. So I'm just going to rerun all my cells. Not found in the access. Yeah, very good. Yeah, of course. I will have to run everything now. I will have to run everything now. Give me 2 minutes. Let me just come down and let me run all the fields. So I'll go to cell. I'll go to run all. In the meanwhile, when it is running, maybe if you have any queries, please go ahead.
No questions as of now.
Now it has worked. And my Y is what? Telecom churn, right? So I have X, right? And here I don't have any churn column and I have Y, which has the churn values, right? I have not lost any data if I'm not wrong. Let me just see, 11 and then info 7032, yes. So just a moment, in place is equal to true I did and 7032, yes. But why is there 7042 here? Oh yes, of course, yes, that's the index number, sorry. Yes, okay. I hope this is a good thing to do. So what I will do now, just a moment, let me just close couple of applications from the backend, and I will close this one also. And then what I would like to do now is that I have X and Y. So I would like to do X train X test Y train Y test is equal to train test split, and I pass X and Y, and I say test size is equal to 0.3. Okay, and I say random state is equal to 101. Now there is a particular reason I selected test size equal to 0.3. That is my personal practice. And the reason why I do this is because whenever I see any data where I have more than 5,000, 6,000 rows, right, that gives me good confidence. If I have myself done the data engineering, that's even brilliant. So it gives me very good confidence that yes, I can use 30% of my data for testing purposes, and that testing data will have good variety because I have good amount of rows. Now, if I had, let's say, only 200 rows or 300 rows or 1000 rows, I would have gone with the default value of 0.25, or I would have actually increased it. So let's say test size, I would have increased it to 0.4. But then there is a problem. If I increase test size, my training size gets slow, and then that can cause yet another problem. So I have to be very careful. Okay, I have to be really, really very careful. Now what I have to do is that now comes a very, very important part. Okay, from sklearn dot pre-processing, and you are not going to like this at all. Import. Why you are not going to like this is as simple as we have already seen that we did the standard scaling for linear regression use cases. Just a moment. Uh, okay. So the reason why we are doing it over here, because as a standard practice, we must always scale our data whenever, okay, whenever we are going to use any machine learning model which plays with distances. Okay, and that distance has a particular effect on that model. In our linear regression also, distance had a very important role. Why? Because more the distance, more is the error. If the best fit line is not close enough to all the points, right, then there is a distance between the actual point and the predicted point being higher, and that distance being higher is actually a problem, because then my r square will not be good, because my mean squared error will be higher, or my root mean squared error will be higher. And that's the reason why we did scaling in that case. It didn't help. Okay, it didn't help at all. We have seen that our by default model without any scaling worked. But we are going to try this over here because this is a classification use case. And in classification use case, because you are not creating a best fit line, but rather a decision boundary, because you are creating a decision boundary, that is the place where, or this is the place where standard scaling really, really helps. Please note, min max scaling does not help. Why? Because it does not convert your data into a Z score. Because it does not convert your data into a Z score, standard scaling is actually comparatively better than min-max scaling. However, this is not to define, okay, this is not to define the goodness or badness of any scaling technique. Ideal condition, you should try it out, see both the models. So we may want to create two models here, one model with standard scaling, one model with the min-max scaling. Now the question is, again, I'll do a telecom.info. If I see all of these columns are the ones which I have already calculated, right? Also, I have a target column. Rest everything is something that I have calculated, and they are categorical. They are like 0, 1, 2, like, or 0, 1, 2, 3. So is that making sense to standard scale them? The answer is no. It is not making sense. What makes sense? Uh, what makes sense is to actually convert. Okay, is to actually convert uh, those fields, or to standardize those fields, okay, which, okay, which are actually continuous in value. So which are the fields which are continuous in value? Tenure. Then we have the monthly charges. Then we have the total charges. Churn is not a continuous field. We are not going to touch that. Is senior citizen a continuous field? No. Everything else is not a continuous field. Right, in the 26 columns, in the 27 columns which we have, there is only tenure field, monthly charges field, and the total charges field. These are the fields which are having continuous value, and that's the reason why we will only take these three columns and scale them. So to do that, what we are going to do, we are going to create an object scaler, which is standard scaler, and we will create that object, and then we are going to do what? We are going to do a fit transform on what? X train. X train is equal to X train, or maybe what I can say, not the entire data. I just need these three columns, right? So why to take the entire data? I need three columns only. So I need the tenure, then I need the total charges, and then I need the monthly charges. Let me just see if I have done any typo. Monthly charges is camel case, total charges is camel case, and tenure. Yes, so this is fine. I believe this should work. This is equal to, okay, scalar dot fit underscore transform, and then I'm going to pass on these three columns. I'm going to pass on these three columns within this function, and it should work. So what I'm going to do, I'm going to simply take this value from here and I'm going to put it over here, right? You can ignore this. You can ignore this. This is just a warning. This is just a warning. Okay. It is actually suggesting us to use this function called lock. Okay. Lock is a function, or ilock is a function which you can use on top of a pandas data frame. You can read about it. Maybe quickly we have, or briefly we may have discussed it earlier. Lock and ilock gives you the capability to slice and dice the fields. Okay. Now this error can be ignored, and now we have extrain. Okay. Now the question is, could we have done this with the testing data also, or could we have done this with the entire data also? That is not suggested. That is not suggested to be done. The training has to be proper. The training has to be good, right? And that is the reason why we do this only with the training data of the features. We will never ever in our lives scale the targets. We will never scale our targets. We should not scale our targets. Why we should not scale our targets is because targets must be represented as they are, or otherwise our machine learning models will not be able to find out the patterns which are there in the data with respect to the target. With respect to the target, we have to find the patterns. With respect to the target, we have to find the variations in the data. That's why we always and always, in case of classification models, by default, we only scale the training data. This is not to say that you cannot scale the testing data, which is otherwise represented by X test. You can do that. There is no negative side effect. Okay, ideal condition, we do not do it. Maybe in this use case, might be we will do this, but we will see that on the next day. So we can take a logical stop over here, and we are going to continue tomorrow. I think I have not uploaded the materials of at least the last two sessions, which I will do. So I would strongly recommend you go through this. If you have any queries, if you have any doubts why we are doing this or why we are doing that, please do some research from your side also, and you can also let me know.
Sure, sure.
Yeah. Okay,
Okay.
Rohit. Thank you so much.
Thank you. Good night.
Good night.